Here I am going to show you a very important inequality comes in complex numbers, which is z1 plus z2 mod is less than or equal z1 mod plus z2. So this is what we are going to prove. So before we go into details, I'm going to show you some important derivations here, which is some of them you know, but I will show you how to do those so that you will understand better. So you know, if z is equal to x plus iy, so then c mod squared can be written as x squared plus y squared, which is real of z squared plus imaginary of z squared. So from here one can see that z mod squared is greater than real c squared and imaginary c squared. So c squared is greater than both real value and the imaginary value. So this will tell us that z itself greater than or equal the real value of z, and this will be valid for imaginary z as well. So now we can go into our derivation. So we have z1 plus z2 here, the mod squared, which we can write z1 plus z2 times z1 plus z2, the complex conjugate of the whole thing. Furthermore, we can simplify this. The complex conjugate can be considered individually. Then we can simplify this further. So when you simplify z1 conjugate plus z1 z2 conjugate plus c2 z1 conjugate plus z2 conjugate. So it is well known that z1 conjugate is nothing but z1 squared plus, this can be written as 2 times real of z1 z2 conjugate plus z2 mod squared. So now I'm going to show you. Now this is my second equation. Before I do more, I will show you how this z1 z2 mod, sorry, this is not c2, this is z1, how that works. So let z1 would be x1 plus iy1, z2 should be, again it's not z2, it's going to be z1 conjugate, that would be x1 minus iy1. So if you multiply these together, z1 conjugate, this would be x1 squared plus y1 squared. You can see this very easily. So that would be your z1 squared. So that's why here we are using that z1 squared. So similarly, we can show that this would be c2 conjugate. Also, now we will try to see what will happen in z1 c2 conjugate plus z2 z1 conjugate. So here I would say x1 plus iy1. Here I will have x2 minus iy2 plus, here you have x2 plus iy2 times then z1 conjugate, so that would be x1 minus iy1. So here one thing to note, that z1 we took as x1 plus iy1, and z2 we took that as x2 plus iy2. So this will help you now. So now we have to simplify that. So let's see. So this one would be x1 x2. So then I have minus iy2 x1 plus iy1 x2, and I would write this directly plus y1 y2. So plus, now this part we have to simplify. So I would say x2 x1, then what I will do, I will take I out, so I will try to simplify this as it is. So let's see, x2 x1 gone, so here you get minus x2 y1, then you have another term there plus x1 y2, and that's all about it, and then you have y1 y2. So this is what it is. So now what we can do, we'll try to simplify it more. So you have x1 x2, then if you get plus I, here you have x1 y2, then minus, then plus y1 x2, then you have y1 y2. So since I have y1 y2 y1 y2, I will put 2 here, and then I have x1 x2, and here x1 x2, I will put 2 here. Now I wrote this one over there, so now I will try to tackle this part. So plus I, now I get x1 y2 minus x2 y1. So nice. So if you can see, you can cancel these two terms because they are going to cancel out. So now this would be 2 times x1 x2 plus y1 y2. So this can be written as 2 times real z1 z2 conjugate. So that is a very important relation, that if you look at this I have written as this, and the proof is already shown here. Now what you can do, so I will rewrite it so that it will be clear for everyone. So real z1 c2 conjugate plus z2 mod squared, that would be z1 plus z2, the whole thing squared. Now we know one thing. So what we know now, this we can say real z1 z2 conjugate is less than z1 z2 conjugate mod. So this is what we have seen before. We have seen that z mod is greater than, you can put equal as well, equal real of z. So this is the most important relation that we have taken. Now, because of that, you can have that less than or equal sign, and then you can replace your z1 z2 bar mod. So 2 z1 z2 bar mod plus z2 mod squared. So you have z1 plus z2 mod squared here. So now if you carefully look at this, you can write z1 z2 mod squared, and then this one you can write in this way: z1 mod plus z2 mod, the whole thing squared. So now you can take the square root of this, so that would be z1 plus z2 mod should be less than or equal z1 mod plus z2 mod. So we have proved this relation, which is important, which is very, very important for VCE special math students. Okay, thank you and see you next time.